Hello everybody and welcome to this workshop where we will talk about Chrome in the industry, why it's a good solution, why it became a problem and how we may fix it. So my name is Marc Alessandri. I'm the general manager of COYARD, which is a medium-sized company based in France who produce valves for critical applications, especially nuclear. We'll talk about this a little bit later in the presentation. So, first of all, a little bit of history about Chrome. So, Chrome, the element was discovered in the 18th, and it developed sequentially, and especially in the 50s, 70s, with beautiful chromium on cars, electric appliances, food industry, and it became the material of choice. We find chrome everywhere, and in the valve industry, you can see many products with chrome inside. However, 20 years ago, the first studies came and found out that it starts to be a problem because of toxicity. So what are we talking about currently? So Chrome is clearly an obvious choice, and this is the reason why over the last 50, 70 years it became the obvious choice. It has a good wear resistance. When you have got a valve you operate, you want it to last long. So good point. Excellent corrosion resistance. You have got fluids which can be corrosive and you don't want the valve to degrade. Excellent choice. Low friction coefficient. When you want to maneuver as easily as possible, it's good to have a low friction coefficient. So excellent choice also. Chromium plating comes with high hardness. So that's also a good point for the longevity of the valve. Nuclear industry today requests a valve to be designed to last for 60 years. So you need to put all the chains on your side, and this is a good point. It's compatible with a large variety of fluids. So basically this is why we find chromium everywhere in food industry, in automotive application, seawater, nuclear, etc. So chromium, at some point, is more or less the incredible solution. So this is why we find it everywhere. So why is it a problem? Because it's so good. So to understand why it's a problem, we need to do a little bit of science. So chrome exists under three forms. So the metal chrome, you don't find it in the nature. It's man-made. And that's the form you have in front of you right now. This form is inert, no toxicity, no problem. But to get to this form, you need to apply the chrome. And to apply it, you go either through hexavalent chromium or trivalent chromium. The application, it's the process we've seen earlier, the process of bath developed in 1924. During this process, you are in liquid form and there's gaseous emissions of chrome. And these ones are very, very toxic. They are cancerous, they are very bad for people, very bad for the environment. Even that at some point, European Union banned chrome in its very first RoHS and REACH legislation and says this is a product we don't want. But as far as European legislation is concerned, there are some pressure because all the industry is using this material. So even if we don't want it because it's toxic, everybody is using it. So there is in the regulation an appendix which says that you may submit case in case no alternative solution is available. And until now, everybody has taken this status quo as the best option. So at COYARD, we found that Chrome is a problem, it's toxic, and at some point we need to face the problem, we need to recognize it, and not push forward the problem for the next generation. So how do we handle this? There are two ways to do. The traditional method is keep working with the exemption. Okay, if a supplier stops, let's find another supplier. So this other supplier may be equipped with filters, so the problem is still there but contained, or based in another location which doesn't recognize European legislation. And if you have components sourced and manufactured in exotic locations, you find companies that have no problem working in bad conditions with hexavalent chromium. That's not something we want to do. Nuclear industry, we consider, should be a responsible industry. And as a small company, we want to go in the right direction. So we didn't want to go to this direction. And the other solution would be to work with chromium-free, which is widely pushed on the market because of decorative chromium that you find in your bathroom. And to get the shiny aspect, that's the alternative. But with this alternative, as we've seen before, the additive we put in the bath are toxic themselves. So we shift a toxic problem for another toxic problem, not a good solution. So what we decide to do is, okay, maybe there's another process, another thing that is at least equal or maybe even superior, because the technology has evolved since the 1950s, in terms of characteristics that our customer value. So our teams worked and found some techniques which are based on thermochemical diffusion process. So it's processes that are known from the industry, but not applied in these conditions. The main hurdle we had to overcome is we address industrial activity, and we address customers who don't want change. They are afraid of change. They don't want to have a problem anymore, but they don't want to be the first to try something new. So how do we bring them an innovation and reassure them? So we had the chance at COYARD to work with the aerospace industry, and especially a startup which develops a rocket and which is willing to take risks. So that's the Elon Musk's SpaceX spirit. Let's try, and even if it explodes, we would have learned something valuable and move forward. And for this customer, this industry, we were able to push the process to demonstrate it works. And based on this experience, we brought it to the nuclear industry on a first project where we say to our customer, if you work with us, you will have, until a certain point in the project, the choice to go with standard chromium qualified product or the alternative process. No extra cost. And we proved the customer that it's a good process, and it shows that. So we're quite happy at the end. And so the process early this year in January has been qualified for nuclear application. And since January, several hundreds of valves are deployed now on nuclear power plants in France. So it's not something we dream of, it's something which is done. So how does it translate to metallurgical aspects? It's a process where we treat the very thin superficial layer of material giving it some extra strength. So this process consists of the solid insertion of nitrogen atoms within the crystalline structure of the metallic surface. The interesting thing is it only affects the surface on a very thin layer, few microns. Which is very interesting also is that we don't have carbide formation, and carbide is bad for the long term because it can make the surface brittle. It can be some points of corrosion. So that's a thing we want to avoid. And this little extra material we add within the atomic structure will make a denser atomic structure, will push the atomic structure together, and it increases the surface density and generates compression constraints. So it's been a little bit technical. How does it translate regarding customer and functional point of view? It translates basically compared to the chromium coating in roughly the same characteristics. So we increase the hardness, we increase the wear resistance, we also increase the fatigue resistance, we lower the friction. We are still non-magnetic, which could be important in some application. And we even bring some additional benefits because the thickness are even smaller than the chromium coating, so we don't change the geometry, meaning that you need a very good geometry at the beginning because you won't correct any small defects, so it's an additional constraint. And you still keep the ductility, so the softness of the material underneath. And so that's a very good thing to have hard and soft, it's like composite structure, because you get the best of both worlds. You really get the benefits. And it's a really homogeneous process. So when you coat with chromium, you need to take your part at some point, and at this part you get less deposit or some problems. This is something we don't encounter with this thermochemical process. So as far as applications are concerned, in valves, we can quote several parts. So sphere are the main ones, but also the stems, and more generally, all moving parts, all friction parts, all guiding parts could be good candidates for this coating. In terms of final product, we've applied it already since beginning of this year on ball valves, which were the first application, check valves and globe valves. So it's really a versatile project. And we even push a little bit forward because we started with a regulation conformity objective regarding REACH. And we also worked on PFAS to have products which are fully REACH and RoHS compliant. So really we want to move forward in this environmentally friendly process and product. So not only the product is good, but also the process to come to the final product are good. And as I said, is not a dream, is a solution. So we did qualification at COYARD. So at COYARD, we are 75 people, so small company based in France. Half of the company is within the offices, engineering, quality department, etc. Half of the company is in the workshop. So we do machining, we do welding, we'll do assemblies, testing internally. And we have some nice tools. So we have got a clean room, and within this clean room, we've got a fatigue qualification bench where we can undergo several hundreds or thousands of cycles within pressure and temperature. And so it allows us to get some qualifications. And we already supplied to all these customers the product, and they already have deployed, for most of them, on the French nuclear power plant. And it's coming also to HPC in UK right now, and in the next years to Sizewell, etc. And we hope that we pave the way for a new standard. And we have some colleagues from other valve manufacturers in the room, so maybe it's some inspiration that you get on your product to overcome this chromium issue as well. So our goal really is, can we do something good for this industry and pave the way for something better? So the question is then, how can we help you now for your project? We've got wide variety of portfolio of products, instrumentation valves, steam valves, ball valves for various applications, check valves, filters. The company has nearly 100 years of experience, so it will be next year our first century of existence. And we would be really glad to exchange with you now directly. If you have some questions or if we can work together, we will take a time in the workshop area to discuss. And we've got a booth right over there, B083. So feel free to come and meet our teams, see our product, touch them, and discuss. It will be great to exchange with you. So I'd like to thank you and invite you for the next exchange.